Welcome to solverfy.
For this problem, they are wanting us to find the mass of nitrogen when nitrogen is introduced into a barometer and we have a mercury displacement. So they tell us that the height of the tube, or length of the tube, is equal to 1.00 times 10 to the second centimeters. They tell us that it has a cross-section equal to 1.20 centimeters cubed. They tell us that height 1 of our mercury is equal to 74.0 centimeters. And they tell us that our height 2 of mercury is equal to 64.0 centimeters. They tell us that the temperature is equal to 24 degrees C. I'm just going to add 273 Kelvin to this. So our temperature is going to equal 297 Kelvin. So we need to figure out what our pressure in atmospheres are. And then we also need to figure out the volume in liters. And we are asked to find the mass of nitrogen in grams. So first, let's find the volume of our tube. So our volume is going to be equal to our length times our area. And we're going to treat our cross-section as our area. So our volume is going to be 1.00 times 10 to the second centimeters. And we're going to minus 64.0 centimeters because we want our volume before nitrogen was introduced. So, and then we're going to times this by 1.20 centimeters cubed. Alright, so our volume is going to be 43.2 centimeters cubed. And then this is going to equal, and we want to turn this into liters, so let's times this by 1 liter over 1,000 centimeters cubed. And then our volume in liters is going to equal 0.0432 liters. Alright, so now that we have our volume, let's find our pressure. So our pressure is going to be equal to our change in height divided by 600 or 760 millimeters of mercury. So our change in height is 10.0 centimeters, and we're going to times this by 10 millimeters for 1 centimeter, and then we're going to times this by 1 atmosphere over 760 millimeters of mercury. So this is going to get us our pressure into atmospheres. So our pressure is equal to 0.1316 atmospheres. Alright, so we found our pressure and we found our volume. So now we can look for the moles of nitrogen. So PV is equal to nRT. We need to solve for n, so PV over RT. So n is going to equal 0.1316 atmospheres, times that by our liter, 0.0432 liters. We're going to use 0.0821 as our R value, liters, atmosphere per mole Kelvin. And we're going to times that by our temperature, which is 297 Kelvin. So our moles is going to be 2.33 times 10 to the negative 4th moles of nitrogen. And then we know that the molar mass or mm of nitrogen is equal to 28.01 grams per mole. So our mass of nitrogen is equal to our moles of nitrogen, so 2.33 times 10 to the negative fourth mole times our molar mass, which is 28.01 grams per mole. So our nitrogen mass is equal to 6.53 times 10 to the negative third grams. So this is the amount of nitrogen that was introduced into our barometer.